All right, everybody, let's talk about lesson 2, which is hydrocarbons. Hydrocarbons are organic compounds that only contain carbon and hydrogen. So they are very specific, and there are very specific ways that we name them, very specific rules that we use that talk to us all about their bonding, how they're arranged. So there's homologous series. That is a group of organic compounds with similar properties and structures. Table Q in your reference packet gives the general formula and examples for how we name these things and what their structures would look like. So when we look at Table Q, there are three main kinds of homologous series. There are alkanes, which are just carbon-hydrogen chains, and we have alkenes, which are also carbon-hydrogen chains, and we have alkynes, which again are carbon-hydrogen chains. Now, the biggest thing we need to know is that there's a general formula that they are going to follow. So for alkanes, it's the number of C's is going to be a certain value. And to get the ends, we take 2 times the number of C's they have plus 2. And these are all going to have single bonds on them. It's going to be a carbon chain strictly with single bonds. Alkenes are going to be a carbon chain, but instead of having all single bonds in them, they are going to have a double bond. That's why they end in ENES, which will be alkenes. So we're going to take the number of carbons that they have, and to figure out the number of hydrogens they have, it's just going to be 2 times the number of carbons. And again, they have double bonds in them. Now the last one is alkynes. Alkynes are different in that they are going to have triple bonds between their carbon atoms. Now, how do we figure out how many hydrogens there are? We're going to take the number of carbons times 2, and then we're going to subtract 2, because 2 of those hydrogens are going to be lost because of that triple bond. So, there are 2 types of hydrocarbons. There are saturated hydrocarbons, and I want you to remember saturated, and remember that these types of hydrocarbons have single bonds only. They contain the maximum number of hydrogens possible. That is why they are saturated. So saturated hydrocarbons have only single bonds in them. SS, S for saturated, S for single bonds. So then, what do we call these things? We call these kinds of hydrocarbons alkanes. Now these alkanes are going to be the only group of saturated hydrocarbons with the general formula of C to some number N. And for the number of H's, we're going to use H equals 2 times the number of carbons plus 2. What do we use these kind of things for? We use these things for burning, so for fuel. So propane is one of them. So when we look at these alkanes, remember they have that general formula. It's going to be C, number of C's, so some number N. For the H's, we get 2 times N plus 2. And their structures are going to be these long carbon chains, and on either end of the ending carbons of this long chain are going to have 3 hydrogens around them. So, how do you name alkanes? You count up the number of carbons, and then you're going to use table P in your reference packet to determine the prefix. So, if it has 1 carbon, it's going to be meth, 2 is eth, 3 is prop, 4 is bute, 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. And then after that prefix, you just add ANE. And it tells you 2 things. Number 1, it tells you how many carbons are in your chain. And number 2, it tells you that they're all singly bonded together. So let's look at this example. So we have C5H12. Okay? So we have 5 carbons in it, which means that we have to use the prefix pent. And since it follows the C to the N, and then 2 times N plus 2, which means that we would have 2 times 5, which is 10, plus 2 more, which is 12 hydrogens, we would call this thing pentane. So again, one more time. We have 5 carbons, so that means that I have the prefix pent. They're all single bonds, and so they're going to end in A and E, and that's because we know this formula. Remember this formula, C to the N, H to the 2N plus 2 tells us how many hydrogens we have. So the name for this compound, C5H12, is pentane. And it follows within our alkanes formula. So let's look at these two practice problems where we're going to name these alkanes. So pause the video and unpause when you're ready. Great, well, welcome back. Well, you should have looked at the first one. The first one only has one carbon in it. And again, it's a saturated carbon. And it follows the formula of C to the N, H to the 2N plus 2. So the first one's going to be methane. The second one, we have two carbons in it. So we're going to go to this F prefix here. And it follows the same C to the N, H to the 2N plus 2. So that means that the second one is going to be ethane. So you should have gotten methane for the first one and ethane for the second one. What about the second type of hydrocarbons? The second type of hydrocarbons are called unsaturated hydrocarbons. This is because they have at least one double or one triple bond between those carbons. They're not saturated with hydrogens. That means they don't have a lot of hydrogens in them. So we have two examples here. We have this example of a hydrocarbon that has a double bond here, and we have this example of a hydrocarbon here which has a triple bond. These are both unsaturated hydrocarbons, just for the pure fact that they either have a double bond or a triple bond in them. So the first one is alkenes. Alkenes are a group of unsaturated hydrocarbons with the general formula C to some number N, H to the 2 times N. And this contains one double bond. And it's always going to have twice as many hydrogens as carbons in the formula. So again, it's going to follow our structure that we're used to in our table Q. So when we name these alkenes, what we do is we name them the same way we name the alkanes. So we use our prefixes to tell us how many carbon atoms we have in our compound. Then at the end, we add ENE, and that tells us that there's a double bond in that structure. So let's look at this example. Okay? This example has 5 carbons in it, so again, we're going to go to that prefix pent. It contains a double bond because it follows the C to the N, H to the 2N formula, which means that we have to end it in ENE. So this name for this structure is going to be pentene. Pent for 5 carbons, ENE because there's a double bond in the structure. So let's practice naming the following alkene structures. So pause the video, unpause when you're ready. Great, well, welcome back. Well, the first one you should have came up with has 2 carbons in it, so you should have gone to F. Since it's alkenes, it should end in ENE, so it should be ethene. The second one has 4 carbons in it, so you should have went to bute, because that's 4 carbons, and added ENE, so you should have gotten butene. Easy enough. So now let's look at the alkynes. Alkynes are another group of unsaturated hydrocarbons with the general formula C to the N, H to the 2N minus 2. And so that means that it's going to contain a triple bond somewhere in the structure. So when you're looking at these, you have to think about these differently. And the biggest thing for you to think about when you're naming alkanes, alkenes, and alkynes is you need to look at what their formula is telling you. Their formula tells you everything. So when we are naming alkynes, we're going to do the same thing. We're going to use the same prefix, but instead we're going to end in YNE. And that YNE tells us that they have a triple bond in them. So let's look at this example. We have C5H8. C5H8, we have 5 carbons, so again, we're going to go to pent. It contains a triple bond because of the formula, and we're going to end that pent with YNE, which is going to make it pentyne. So let's practice naming these alkynes. Pause the video and unpause when you're ready. Great, well, welcome back. What did you come up with? The first one has 4 carbons in it, so you should have come up with butine. The second one has 2 carbons in it, so you should have come up with ethyne. This is as difficult as this is going to get. The biggest thing that you need to remember when you're going through and naming these structures is the different endings mean something, and you need to be able to distinguish between what they mean. So how do you determine the type of hydrocarbons using table Q? The first thing you need to do is count up the number of carbons. If the number of hydrogens are double than the number of carbons, then it's an alkene. If the number of hydrogens is more than double the number of carbons, then it's an alkane. And if it's less than double, it's an alkyne. So when we look at this, we have C5H12. 12 is more than double 5. So that means it has to be an alkane. So you're going to name it with an A and E at the end. Okay? So let's look at some of these practice problems. So pause the video and unpause when you're ready. Great, well, what did you come up with? The first one, 6 is more than double of 2. So that means that this is going to be an alkane. So it's going to have to end in A and E. Has 2 carbons, so you should have named it ethane. Second one, C5H12. 12 is also more than double 5, so it should end in A and E again, and this should be pentane. 6 is directly double the 3, so then that means that this is an alkene. So it should end in E-N-E, and there's 3 carbons in it, so that means it should be propene. And the last practice problem, 6 is not double 4, so that means it's an alkyne, so it should end in it should end in Y-N-E, so then you should name it butane because there's 4 carbons in it. All right, let's look at this, check your understanding. We're going to answer this one first thing tomorrow in class. Have a good night.